So welcome to this episode of Seen and Solved. I'm your host, Tim Pennington, and today I'm being joined by two real experts in the metal finishing industry, product manager Jason Potts and business development manager and plating pro Tom Salvino. Gentlemen, welcome. Thank you for joining us today. Appreciate it.
Thanks, Tim.
You're listening to the Seen and Solved podcast brought to you by Hubbard-Hall. Better results, less chemistry.
So the topic today is going to be electroless nickel. I know, years ago I used to go to electroless nickel conference and people would come there, a few people, and they just were bewildered by it sometimes. So I'm glad we can kind of talk about electroless nickel as a topic, EN we'll call it, and what you all do to help some of your customers. Let's talk in general. Maybe I can ask each of you to kind of jump in and tell me the last EN problem that you faced with a customer and kind of how you solved it. Give us that sort of feel of how that went.
Tom, you want to go first? You were going to talk about the liners that we saw issues with.
There is a lot of different issues that we see with EN and tanks, we had a peculiar instance where purchasing decided they were using a liner instead of a straight poly tank or stainless steel tank. They were using this liner, and the purchasing department decided that they were able to get these liners cheaper. They bought a black liner and didn't know that they changed vendors, and it had a very high carbon content in there, and the bath kept plating out. And we were called in for this problem, and boy, did we run around trying to figure out, look at the stabilization of the bath. You look at everything. You don't realize somebody's changing out a tank liner on you, and it came out to be the tank liner was just causing the problem. As soon as we got rid of that tank liner, the problem went away.
So explain to me that. Why was the tank liner causing problems? Tell me why that's different and unique in EN.
Because of the carbon content, the way it was explained to me, that the carbon content was just causing the bath to start to plate out.
Okay. The carbon content that was actually used to make up the liner was sort of coming off of that. Gotcha. Good point.
And it's a unique one. It's not something you see every day, but it was intriguing.
And that was probably the last thing you checked, right? After checking everything else.
Yes, you go to the basics. You just go right down the list. Let's take a look. Let's look at stabilization. Let's look at all that. And yes, it's one of the last things you would look at.
Jason, what about you? What's the kind of the last thing you've worked on lately with the EN?
I would say the last thing is it depends on the application, what they're trying to process. A lot of times, we get in situations where there's a high build application to where we're talking thousands or more of EN. And there's certain tank designs or issues that can be brought up because of the fact that the tank was designed wrong, mainly for filtration. For those high build applications, I've seen applications to where their filter themselves, maybe they're using too large of a filter, maybe a 10 micron filter where they should be using a 1 micron. So that design was wrong, or not using a slope bottom tank to capture all the particles. So you end up getting particles falling into the bottom of the tank and they can't get sucked back up by the pump. Subsequently not getting filtered at that point because they're laying on the bottom of the tank, and then you get played out and you'll have a whole bunch of other issues because of that.
Before we get into talking about tanks and specifically some of the issues that come up, do you all feel that, because I kind of get the sense, and maybe I'm wrong, is that EN's a little bit of a challenge for some people to get it right. It's a little bit more difficult than just some of the other process. Do you feel that way? Or
Yes. I kind of chuckle at that because, with EN, you think about with EN, you're not plating, you're plating out of the chemistry itself. You're not plating from an anode. So therefore control is important. You have to add back the chemicals in order to keep the bath going. So it can be very difficult. It can be difficult. I should say, yeah, it's difficult, but with the right training, the right controls, it could be just as easy as any other plating bath.
And when you're talking controls, you're talking parameters, because I know we're going to be talking about tanks, but just really understanding what should be in a proper setup, right? And adhering to that and staying with that, correct? And staying in the parameters.
Yeah, the parameters, definitely. That's what I'm referring to. So you have a set parameters where you have to be, and those checks have to be done. If they're not done, you'll deplete the bath, and then you can run into a whole array of issues, whether it be slow plating, plate out, roughness, edge pullback. There's several. We've seen quite a few different, Tom and I have seen quite a few different issues over the last many years, I'm sure.
I wouldn't say that it's harder than other processes, especially when you work with so many other processes. That opens up a whole nother box. If you set up an EN tank correctly, you have controllers, you have the right equipment, and you're doing a repeated parts, you can set it up where it runs fairly smoothly. And then when it comes to the end of the life, you just dump the bath, you make up a new one. So there's a lot of positives on EN as compared to like a decorative nickel, cyanide copper, acid copper, things like that. They can get complicated because there's so many steps in between.
So let's talk about tank design. What issues do you all see most common with tank design out there in the field?
A lot of the issues that I've seen, I'm sure Tom and I will probably have different stories on this, but a lot of times the tank design itself, so not so much the design, but maybe the size of the tank. If an applicator comes up to, somebody that's going to build the tank, and they explain that the parts that they're going to be plating the size of them, maybe they oversize it or undersize it, because EN has loading issues. So, tank design is important in the size of the tank, but also on what you're trying to accomplish. Again, we could go back to the high build applications where you have a work bar agitator. You want to make sure that you have good filtration to where if you were doing general job shop, maybe 2 to 5 tenths, you don't need those kind of controls on that tank to accomplish what you want to get in the end, which is typically with high build, you want a pit-free deposit. So there's many design factors that have to go into play when building a tank for something like a high build application.
Tom, your thoughts on that? Any issues that stand out that you think are with the design?
Replacing a tank when it needs to be replaced instead of trying to extend the life, because you're stripping these tanks constantly. The poly has a tendency to break down and has sites where you can start plating out. We see a lot of old tanks that people tend to just try to keep them working when you really should replace them. And it actually, if you did a cost analysis, it's probably cheaper to replace the tank because of the money you're saving on not plating out solution.
And especially, you certainly don't want to reline the tank.
It depends if you're going poly or stainless. If it's a poly tank, it's easier just to, it's easier just to have a new tank built.
I have many applications to where they do put Tim, as you said, put a thick poly insert into them. But then there's plumbing issues a lot of times with that if it was already directly plumbed in. But that does happen, and we do see that also.
So let's talk about tank design. So what role does tank design have in an EN system?
If it's designed correctly, it can eliminate a lot of issues, especially on high build, because you have the correct flow, you have your correct filtration. I've also seen instances where people have taken that a step too far and they put too much agitation in there. I had one tank that was built, and great company, and they went overboard engineering it, and they had 3 pumps on the tank, 1 for filtration and 2 pumps for the eductors, and they just had too much solution movement in there. And once we shut down one of the pumps, all the issues went away. So you can over-engineer. Normally you're going to walk into a situation and you're not going to have enough filtration or you're not going to have enough agitation. That's the norm. To see it the other way is rare.
When a tank is designed incorrectly, what are some of the symptoms? What are some of the things that will happen when that occurs? And
Jason, you can jump in, but some of the things that you want to look at, you want to make sure that you have good agitation where you're not getting localized heating at the heaters too. And cooking the solution, that becomes an issue.
Yeah, definitely localized heating I've seen to where there could be a huge debate on what type of heat you should use on an EN tank. Some will swear by heat exchangers. Some are over the side electric, those round, the derated, which is actually, it's not using the total, your maximum capability of that heater, so it doesn't overheat in that area. So that helps out. There's pros and cons to all the heaters. Heat exchanger, you could not, if you don't passivate completely, that'll play down on you. Or if you have the overside, a lot of back in the day, I remember people using, Tom, remember the spaghetti coils?
Yes.
The Teflon spaghetti coils. So they would put those in there, and they would just, basically you wouldn't know when one would break, or you could get some boiler water in there, a lot of drag, or you could hold on to a lot of solution during your passivation and be nitric contaminated. So my personal, if you have the capability to run a heat exchanger doing general job shop work is the way to go. But a lot of times in some high build applications, the dimple plate stainless steel heaters are starting to come and play, but then you have to look at possibly anonically protecting them so they don't plate out as fast.
And also with heat exchangers, when you're stripping them, you have to make sure that they are stripped and passivated. I've seen a lot of buildup in heat exchangers that restrict flow. I've actually seen an easy way. Some people have filters when you're stripping down a tank, I like to open up the filter basket, take a look inside and make sure, because I've seen plate outs still on the bottom of filters. That's an indication that you're not stripping the whole system down completely. There are instances, and we're going off topic here, but nitric acid has a finite life, and it gets saturated, and it's not stripping and passivating the way people think. So that's another issue I've seen out there.
Let's talk about some of the common errors, operator errors that happen. These are mistakes that people are making when they're running their line. What are some that you've seen, and maybe what are some fixes for those? But what are most common ones that each of you take that?
I was going to say the most common one comes right to mind is the hose over the side, and we get a phone call. Somebody left the hose in there last night and didn't tell us, and then we have this problem. We found out that they left the hose in there. And then you have to go back and re-engineer how are we going to save this bath. Let's see where the numbers are. And but that is probably one of the most common things that we hear on a regular basis.
That was the one I was going to take, and I've been guilty of it myself. I've been guilty of it myself as an operator, and even as a supplier, I've made that mistake.
Just leaving the hose over, right? Really, something like that. Yeah.
Yeah, and some of the controls that some of the shops have now, they'll have to where you actually have to hold your hand on a button. And you can't walk away, because if you walk away, it stops it, which is a great fail-safe. But one of the things I would say I see a lot of is just the general nickel titration. Everybody sees colors different, so if you don't run a controller, you're doing a simple nickel titration, and one person may see it as, a purple, maybe a light blue, or a violet. And some people may not see the color at all. So therefore, what happens then is your additions or your calculation is wrong on the amount of nickel and hypo you have to add back, and then you run that bath all day. And if you're low all day, you're going to end up low at the end of the day, or if you're high, you get overstabilized. So that's, I would say that's another common thing. And sometimes it's not the operator's fault. It could be, it actually could be the EDTA they're using, or, whatever they have in the shop. It could be contaminated.
Great. Well, those are some great, like I said, great ideas, great tips. And I know they can call you all to help solve those problems. I know probably the first thing you say is get the hose off the side of the tank and see if that works. I'm sure probably it doesn't a lot of times, but it sounds like it's a common occurrence. But anyway, just want to thank you, Jason Potts and Tom Salvino. Appreciate you guys joining us today.
Thank you.
Great. Thank you.
It's good to be here.
The Scene in South podcast is brought to you by Hubbard-Hall. For more podcasts, visit hubbardhall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Allcast.